All right, so we have a boat being pulled into a dock. And there's a pulley up here where the rope is pulling the boat. And the bow of the boat, which is here, is moving towards the dock. And we're being told that the rope is being pulled in. So put arrows of things changing. So we have the pulley on the dock that is above the bow of the boat is 5 feet. So that's the fixed number, the one fixed number you want to put in the picture. So we have the bow of the boat approaching the dock at 1/2 foot per second. So let's put the B here for the bow of the boat and call dB/dt 1/2. Now this length B is getting smaller, so we're going to make it negative. And we want to find out how fast this rope is changing, so that would be the length of this. I'll call this R. So I want to find dr/dt. And when information is when the bow of the boat is 4 feet from the dock. So that means when B equal 4. So I'm going to save that information until after the derivative. Do not put that number in the picture. So I'm looking for my equation. So I can see Pythagorean. R squared is equal to B squared plus 5 squared. So I'm ready to take the derivative. So 2R dr/dt equal 2b dB/dt, and the derivative of 5 squared is 0. So I cancel the 2's. It's going to happen often. And let's see what I can plug in. So I don't know R, and I don't know dr/dt, but that's my unknown. That's what I'm trying to find. B I know is 4. I can use that now because I've taken the derivative. And dB/dt I know is negative 1/2. So to find R, what I'm going to do is I'm going to put the B equal 4 in. And I've got this side length 5. And I've got to figure out what R is equal to. So this is not your typical 3, 4, 5 triangle. R squared is equal to 5 squared plus 4 squared. So 25 plus 16. So that gives me R equal root 41. So when I go and solve for dr/dt, I get negative 2 over root 41. And it is negative, and that makes sense because this length R is going to be getting shorter as the boat pulls in. So let's do this next one as well. So we have the length of a rectangle. So I don't really need a picture, but I'll draw one just to see what we have. Length of a rectangle is increasing. So I have dl dt is 2. And I'll call this w. And dw dt is 4. And they're giving me 2 whens. When the length is 6 and when the width is 10. Find the rate the area is changing. So find dA over dt. So I know that the area of a rectangle is length times width. So I know I need to use product rule when taking the derivative here. So first d second plus second d first. So now I'm ready to just go plug everything in. So dA over dt will be 6 times 4 plus w, which is 10 times 2, so 24 plus 20, so 44. Okay, so we have a 10-foot ladder leaning against a wall. That's not changing, so we're going to put the length of the ladder in there. The top of the ladder is sliding down, so I know this is the top's coming down, so this length here will be getting smaller. So dy over dt is going to be negative 2 because that length is getting smaller. So when the top of the ladder is 8 feet, so that's telling me when y equal 8, save that information until after the derivative. How fast is this length changing? So I'm going to call that x and find dx over dt. So I see the Pythagorean theorem. So x squared plus y squared is equal to 10 squared. And I'm ready to take the derivative. So 2x dx over dt plus 2y dy over dt equals 0. So again, I'm going to cancel the 2's, and I'm going to see what I can plug in. So I don't know x yet, dx over dt plus, and I'm going to substitute in for y, so 8, and then the dy over dt is -2, and that equals 0. So to go find x, I'm going to put the y equal 8 in, and there's my 10, and then I can solve for x. So I have 100 is equal to 8 squared plus x squared, so 100 minus 64, so that gives me 36, so 6 is equal to x, and we know it's the positive. So dx over dt will give me a positive 16 divided by a 6. And you could simplify that, but let's think about it. It's positive. This length x will be getting bigger, so that makes sense.